Hello, Assalamualaikum. My name is Muhammad Ramzan Hussain. My metric number is BF2030009 and my faculty is FKAAB. And I'm going to present the part of introduction. So, as you know, that rainfall is essential for maintaining all aquatic ecosystems and has a significant influence on water management, planning, flood control research, and the frequency of flooding. In order to offer a trustworthy estimate of various climate changes provision, it is essential to evaluate the past, present, and projected future pattern of annual and seasonal total rainfall. Rainfall is renewable resource that is subject to both natural and man-made influences and is highly variable in both space and time. Understanding the variation brought on by climate changes is feasible by being aware of changes in the predictable pattern of rainfall. Also, we know that rainfall is also a major factor in the design of many other engineering constructions, including canals, bridges, culverts, and road drainage system. So, in this project, the normal rainfall, deficiency rainfall in Kota Tinggi are investigated using daily rainfall data for a 30 days period. A number of floating position equations are utilized to further analyze the return duration of monthly rainfall as they forecast the availability of water and set up the proper storage. Farmers, urban engineers, and planners of water resource will all profit from the knowledge offered by this research. So, thank you. That was my part.
Assalamualaikum and very good day. My name is Muhammad Azim Danabi Alwi, measure number AF19085. So I will present for the methodology part. So the data that we collect is from Department of Irrigation and Drainage website, which is we collect for almost 30 days, and then we use this data to calculate the mean area rainfall and generate the hydrograph. We also use the Google Earth Pro to find the catchment area alongside with the parameters such as slope, length of ridge that we use to calculate the storm duration, and also we use to find the cross-section area. And then all the parameters we obtain, we calculate the peak flow, and we also calculate the estimate water level discharge at the maximum level.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Nur Abid bin Muhammad Siddiq, AF190025. Today I'm going to present my about data presentation. The collection data were from 7 May 2022 until 7 June 2022. The location that we proposed were at Kota Tinggi, Johor. There are 3 rainfall stations, which is Station Hujan Pasak, Station Hujan Sungai Johor, and Station Hujan Ladang Nahing. There is one water level station that we propose, which is at Sungai Johor, Kota Tinggi. We collected the data from the end of the day, which is 11 PM until 12 AM. This is the rainfall data at each station. A is the for station Hujan Pasak, B is for the station Sungai Johor, and C for the station Ladang Nam. This is our water level data at Sungai Johor. Now we jump to the mean area analysis. There are 3 types of method to determine mean area, which is arithmetic method, Pearson polygon method, and isoheighton method. From our arithmetic method analysis, we select 7 days that contain rainfall data, and then we total up the 7 days data, and then we average each from 3 stations, and we got 81 millimeter for the rainfall and intensity. Now with Pearson polygon method analysis. First of all, how do we get the area of the polygon at each station? Okay, firstly, we can take each precipitation line by with a straight line. After that, we constructing a perpendicular line to form a bisector area, and then the area of polygon we got. And after that, we calculate it, we times with the precipitation value, and then we divide it by the total area at each station. And now we got the precipitation is 87.42 millimeters. Lastly, isohydral method analysis. We use isohydral interval, which is 30 mm at each interval, and then after that, the area we got from the Google Pro by forming a identical isohyd lines, and then at each interval that we got the area, and then after that we calculate the precipitation with area times precipitation value at each interval of isohyd, and then we divide it by the total area, and then we got 86.8 millimeters. So from the three analyses, isohydral method analysis were the most accurate from for to get the average precipitation, which is 86.8 millimeters. Thank you.
Hello, my name is Anamara Isal Anak James, CF200232. I will present about the hydrograph based on the data we obtained. As stated, our case study area is at Sungai Johor with the data we obtained for 10 days. The daily streamflow data for a particular catchment having an area of 83.09 km square, where the flow velocity of the river is 0.73 meter cube per second. The weighted parameter of the river is 148 meters square with the average width is 74 meter. Okay, after that we proceed with the calculation. Note that we were not given data for Q total flow, so we have to calculate for ourselves. So as you can see from that table, based on the minimum and maximum water level values, we have made an average for each day. This is because we need to get the R value by multiplying the average water level with average width of the river, which is 74 meter. So by that, we were able to get the Q total flow value. Okay, next we proceed by making the hydrograph so that we can obtain the values for Q base flow and Q direct flow. From that, we can get the values of UH ordinate by dividing Q direct flow with equivalent runoff depth. Okay, lastly, we plot the hydrograph based on the values of UH ordinate, and this is how the hydrograph looks like with the axis of discharge versus time. I think that's all from me. Thank you very much.
Assalamualaikum. So I will continue presentation for calculation of peak flow using rational method. For design RI, we choose 50 years and then we calculate the runoff coefficient calculation. We divide the area into 8 different area and then we categorize it into 4 types of land use, which is residential area, open space, bare soil, spot fields or park, and open space for forest cover. So as you can see, this is the type of coefficient that we obtain, and then we use formula C average to calculate the C average for all of the land use, and we obtain 0.44. Next is the estimation time of acceleration TC. So for the TC, the formula is T naught plus TG plus TD, and the T naught we get 11,020.85 minute, while for TG is 1,000.86 minute. For TD is 35.02 minute. So to calculate TC, we sum out all the value of T and we get 12,056.73 minute. So proceed to the average rainfall density calculation. We use the formula given in the MASMA and then we insert all the coefficient that we obtain from also table from the MASMA, and then the value of I we obtain is 4.04 millimeter per hour. Finally, for the calculation of peak flow, we use all the value obtained and we insert into formula Q equal to CIA divided by 360, and the final value of Q is 41.03 meter cube per second. Comparison between peak flow and estimate discharge. So for the obtained value of peak flow, we get 41.03 meter cube per second, and for the estimation of discharge at Sungai Johor, we get 17,418.38 meter cube per second. We can see that both values have a huge difference. This may be because of error during obtaining parameters such as TC or maybe lack of reach using Google Earth, and then the rational method also is not suitable to calculate the peak flow because our catchment area is bigger than 80 hectare. So all of these factors can lead to error during calculation.
Okay, so for the estimation discharge of the river at the maximum water level, the location we choose is Sungai Johor. As you can see right here is at the Google Earth. From this Google Earth, we get the cross section of the river, as you can see on this diagram, and then construct the table to make our calculation easier. Move on to the calculation. So based on that table from the previous slide, we make a new table to calculate the cross-section area, the weighted perimeter, hydraulic radius, and lastly to calculate the discharge using the Manning equation. So we calculate all the data for 6 sections, and then we get the total cross-section is 5,133 and the total discharge is 17,391.57. Okay, for discussion of our project based on all the calculation that we calculate, we could discuss that the highest minimum water level we get is negative 0.39. The highest maximum water level was 2.25. The mean average rainfall was 81 mm. And using the Tyson polygon method, the value we get is 87.42 mm. And using isohatel method, value we get is 86.8 mm. The total direct flow we get is 62.67 meter cube per second, and UH coordinate is 1.97. And lastly, for the peak flow discharge analysis, we get 41.03 meter cube per second, and the peak flow is 17,391.57. Okay, in conclusion, the fluctuation of radiation climate parameter is recurring phenomenon in the study that we conduct on Sungai Johor. Therefore, we should take into consideration the rainfall with variability in general of the area into climate change adaptation strategy.